All right, question 3. Go paper 1 mathematics. There's this topic. Okay, not a topic, but a question. Mathematics paper 1. And paper 2. The first question, algebra. Okay. It's one of the questions kwamele udopa marks. Paper 2, there's statistics. It's a question where you should grab marks. Organic chemistry, paper 2, physical sciences. It's a topic where you should be grabbing marks. Apai. I think it's there's 3 questions around organic chemistry. You have the IUPAC 1, question 2. You have the physical property questions, or question number 3. You also have question number 4, reaction. So 3 questions on one topic. So there's a lot of marks. Yeah, so it's one of those it's one of those topics where you should be, know your stuff. Thanks for tuning in, guys. Check out the description box for more recordings for this question paper. So sibhekene no question 3, a topic on physical properties like organic chemistry. So basiphe a table ekhombisa boiling points for 4 organic compounds, represented from A to D, of comparable molecular masses. Let's see. Sine propanoate, ester, sine hexane, alkane, another alkane, bese sibanani ne alcohol. Okay, so of course. So boiling points wakhona azoba different, of course, azohlukahlukana. And then we have the okay. So the molar masses are somewhere around the 80s, less than 9. So adlalela between 80 nobani no 90. Okay, so mina, this is what I normally do. Before attempting any question, I try to understand information abangiphe yona. Ngizama ukukhipha even, like, try to reason with it. Uyabona? Try to reason with it. Nangithi uyareasona nayo because ukuthi, you talk to the information ubone ukuthi uyayi-understand. I hope it makes sense. I hope it does. Alright, so 3.1, bathi compounds A and B are structural isomers. Okay, so basibuza ngama-isomers la ku-3.1.1. They want us to define what a structural isomer is. Sinama-isomers ayingaki? We have 3 types, if I'm not mistaken. We have the functional isomer. In a functional isomer, we also have a structural isomer, but I'm gonna define one just to combat my differences. So we have the structural isomer, which is the one abasibuza ngayo. We also have what? Functional, structural. What's the third one, Gwanj? Functional, structural, and okay, what's the third one? Oh, chain isomer. This is the 3 isomers esiwabhekayo, right? But uzoba ukuthi nawufika now uzothatha i-chemistry at a university level, the list keeps on going, right? Kunabu, I think, is it optimal, optical, what's the other one? But lana syllabus yet, we're just looking at 3, right? But there's more isomers than 3, so the list keeps on going. Okay, so what is a structural isomer? So organic compounds. These are organic compounds. Organic compounds with the same molecular formula. Alright, but different structural formulas. Same molecular formula, but different structural formulas. Structural formula. Okay, yeah, sengibhala njengo-doctor lapha. Alright, so structural, same formula, molecular formula, but different structural formula. So that is a structural isomer. Okay, lapha ku 3.1.2. 3.1.2. Basibuza ukuthi what is the boiling point of compound B? Nangu B. No. But the boiling point of compound B is higher than the boiling point of compound A. Right? It's obvious, siyabona lapha. But they want us to explain the difference in the boiling points. Alright, Lana, let me pause for a moment. Explain something when it comes to answering our questions afana nalawo. The differences in boiling points. So the differences in our boiling points, this is what you should be taking into consideration uma uphendula these types of questions. Beg, it's a 3-mark question, right? There should be ama keywords la, right? You have to talk about the energy between ama intermolecular forces, right? Okay, the energy that holds ama molecules wakho. Let me just put it that way. And then you should also talk about the type of intermolecular forces involved, yeah? Their strength as well, right? Then ukhuluma nangani wa energy, type of intermolecular force. You should also touch on surface area. Surface area. Okay, surface area, it has to do with the shape of a molecule. If it's more oval, there's more surface area, because another oval, if an oval meets another oval, the space of contact between them, it's much more greater than when a spherical molecule meets another spherical molecule. So there's less space in a spherical shape and more space in a oval shape. Okay, so that those are the two differences. But touch on surface area if you are talking about ama molecules belonging in the same homologous group. Like in this case, hexane 2.3 dimethyl butane. They belong in the same homologous series, which is ama alkanes. Yeah, what? So to answer this question, you need these 3 keywords. So how do we explain this? Okay, so explain kanjani. Sizothi B has a higher boiling point, right? Has a higher boiling point, has a higher boiling point, has a higher boiling point due to maybe it's not due to the larger surface area of the molecule. Okay, what do I mean with B has a larger surface area? Hexane, it's a long chain. Iso molecule hexane. It's like this, right? It's like this. It's more oval than uluganji, 2.3 dimethyl. Why do I say that? A molecule in ama branches, form like sort of like molecule akhona ifuna ukuba like spherical in shape, as compared to a long chain. Yabona hexane, it's a long chain compared to 2.3. Compound A has a branch. This one ain't a branch. B doesn't have a branch, so isoba more of a long chain, so there's more surface area. So it has a higher boiling point due to the large surface area of the molecule, right? Okay, the larger surface area of the molecule. Maybe ungaqhubeka uthi B has no branches, right? Of course, and we explain just, you know what, just have some context when using lama keywords wakho, right? has no branches, right? And then singaqhubeka mhlambe sithi okay, therefore maybe we can say therefore B has stronger intermolecular forces, right, due to the large surface area. Of course, I understand ukuthi ama alkanes have the weakest ones, right, in ama London dispersion, right, ama London forces, ama alkanes. But due to the shape of the molecule, this increases the strength of the molecule, right? Ngoba another oval molecule na meet another oval molecule, we get large surface area, area of contact. So therefore, the strength of the intermolecular forces does what? It increases, right? So therefore, more energy is required to overcome the bonds. Guess what? Next time babuza a question like this, uzoyi answer the same way. Have context for energy. Have some context for iloganje, type of intermolecular force. Have context for surface area. Don't just plug in lamagama nje. Yabo? Have create sort of like an explanation, explainayo. The relationship of energy, type of intermolecular force, and the surface area, right? Okay, so that's how we answer 3.1.2. Remember, the formula it's the same. It's the same throughout. You just need to use the right keywords. Okay, so 3.2, boiling point. Boiling point, okay, this one we shouldn't answer, but we're gonna discuss the other ones. I think some reasoning. But if vapor pressure, it's something you should know how to define, right? Okay, so the vapor pressure thing, you have a container like this. You have a container, maybe I think you vule the container lapha. Right, siyazi ukuthi the planet has something called let's say amanzi la, this is water. There's something called the atmosphere. So the gases in the atmosphere ayenzani, they have weight, they have mass, right? So that mass of the gases are pushela pans, so they are applying what? Pressure. This is what we call atmospheric pressure. So the pressure exerted by by vapor at equilibrium with its liquid in a closed system, that's what we call vapor pressure. I'm thinking of a boiling point, man. What is vapor pressure? Vapor pressure, let me close it this time. Yes. I'm thinking of a boiling point, but okay. Vapor pressure is the pressure exerted by a vapor at equilibrium with its liquid in a closed system. Alright, this might define kanjalo. So it's the other way around here this time. So we have water. Remember, water, amanzi at room temperature, there's this exchange between our phases, right? Exchanger from liquid to a gas, right? So uma change from this liquid state into the gaseous phase, the molecules are phezulu. So in a closed system, we're gonna get a vapor pressure. So the molecules, the particles are changing from liquid state to a gaseous state. It's what gives a vapor pressure. That's why uthola sometimes isigubhu usikela overnight esinamanzi usithola sesijulukile. So right, lokujuluka lokho, it's, you can say it's vapor pressure. It's due to vapor pressure. Most vula lesigubhu after some time uzwa a little bit of steam nyana. So it's because of the molecules that are changing from liquid to gas, they wanna escape. So in a closed system you have vapor pressure, but in an open one There's no vapor pressure. There is vapor pressure, but izoba incane ngoba some of the molecules are not applying any pressure around the container but they escape. Yabona? So you should know how to define what vapor pressure is. Okay. So 3.3, which one of the compounds B or C will have a higher vapor pressure? Give a reason for the answer. Okay, so lago 3.3 is we compare B no C. These two, which one will have the highest vapor pressure? So in other words, they are asking which substance is it easier for Yona to change from a liquid to a gaseous phase? It's the one with the lowest boiling point. Ubani? B. So it will have a higher vapor pressure, right? So we also have to give a reason for that. It's because of B. B has a higher, a lower. C has the highest one. So B has a lower vapor. Come on. Boiling has a lower boiling point, right? Boiling point. Maybe ungaqhubeka uthi thus making it easier to change from liquid state to a gaseous state. You can go on and explain it ngaleyo ndlela le. Alright, so 3.3 done. 3.4, consider the compounds C and D. C and D. So we are comparing with C and D manje la. Okay, pentane 1-ol. Ha. Yay. Asborn 3.4.1. Okay. Alright, so le two lena yi alkane, right, in our London forces. And then we have methyl propanoate, ester, so it falls under the banner of our molecules with our dipole forces. Then you have the alcohol. It contains the strongest intermolecular forces. Our hydrogen bonds, right? Our hydrogen bonds. Okay, so which will have, will the boiling point of compound D be X or Y? X or Y? I'm gonna say Y for this one. The answer should be Y. I'll explain in the next question. Where was Buzuti? How did we get to ubani or Y? I'm saying Y ngoba u75 less than ubani, 75 less than low 79. And as I was explaining, the hydrogen bonds are the strongest compared to the other two, right? So if our hydrogen bonds are strong and so like pentane 1-ol, we should expect a boiling point a much more higher than everything above, right? So why it's 135.5 degrees Celsius. Explain again. Explain. How do we explain this again? Okay. First of all, we see unama dipole forces, right? C has dipole forces, right? As dipole forces. And maybe D, D being an alcohol, contains or has one, let's just say contains the strongest intermolecular forces. Wonungabhalu IMF lapha ku exam. Write the full name. Because of the penning balangayo manish, it becomes a little bit difficult to write sometimes. It contains the strongest intermolecular forces, which are stronger than okay, the strongest intermolecular forces. Maybe in bracket you can just put in hydrogen bonds. Hydrogen bonds, right? So you have to name drop. You have to name drop. Noma ungayifaka bracket, it's still fine. Name drop, name drop. Hydrogen bond, it's considered a keyword now, right? It contains any hydrogen bonds, right? Which are stronger than dipole, dipole, right? Dipole forces, right? Dipole forces. So therefore more energy will be required. Angsana space, more energy will then be required to break what? The intermolecular or weaken the intermolecular forces in Bani in D, right? So more temperature is required to make alcohol here to do what? To boil. Okay, discussion yethu iphelela lana ku 3.4.2. For this question 3, I hope uthole something in preparation for your exams. Check out the description box for more content creative for this question paper. So for now, asibonane on the next recording. I hope you enjoyed. Ungakhohlwa ukulike, ukushare, and subscribe. So for now, guys, peace.